This video is on solving systems of linear inequalities. We are going to be solving these by graphing. We have 4 examples on here. We're going to find the solution set and we will determine if the coordinate 2, 7 is part of the solution set. So the first step we have to do is to make sure we put them into slope-intercept form, all of inequalities, so that we can graph them by hand. So our first inequality is not in slope-intercept form yet, so we need to put it in slope-intercept form. We're going to subtract the 4x from both sides. We'll have negative 3y is less than negative 4x plus 7. Then we'll need to divide by negative 3. So we'll have y is greater than, because when we divide by negative, our inequality flips. A negative 4 divided by a negative 3 is a positive 4/3 x. And 7 divided by negative 3 is negative 7/3. Then for our other inequality, so we're going to have that one in pink. Our other inequality, we're going to have 2y. We're going to add the x to the other side. We're going to add the x. We'll have 2y is less than positive x minus 6. Then we'll divide by 2. We'll have y is, since we're not divided by a negative, we'll keep the inequality as is less than 1/2x, and then negative 6 divided by 2 is negative 3. So now let's graph. X, y. Our pink inequality starts at negative 7/3, which we can get as negative 2, so negative 7/3. You can get as a decimal. Negative 7 divided by 3 is negative 2 1/3. So negative 2 1/3, about right here. We're going to add 4, so we're going to have a change in positive 4 over a change in positive 3. So 1, 2, 3, 4, 1, 2, 3, about here. 1, 2, 3, 4, 1, 2, 3, about right here. 1, 2, 3, 4, 1, 2, 3. I'll do the same thing going down. So I'll do a negative 4 and a negative 3. So 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. I can go a little off of the graph just so I can have another point. And this one would be a dotted line. So I'm going to make my lines dashed. See if I can get the pink. Now I will connect these dots as best as possible. That's my pink line, my pink inequality. Then I'll do blue. So I won't shade yet because I want to make sure I can graph these without interfering with any of the coordinates. So my first coordinate is at 0, negative 3. My slope is positive 1 over positive 2, so that is a change in y of 1, change in x of 2. 1, 1, 2. 1, 1, 2. 1, 1, 2. 1, 2. 1, 2. I can do negative 1 and negative 2. And just follow that pattern. And this one will also be a dotted line. So I will have that one in blue. The reason it's dotted is because this is just a less than and not equal to. Now for shading, I'm going to go back to my pink. It says greater than, so along my pink line I'm going to shade up all of this section above my pink line. And for blue it says less than, so along my blue line I'm going to shade down. Now the solution set is where the blue and pink both meet, so that's within this section here. Because it's above the pink but below the blue. So I'm going to use a highlighter as well to show that this is the section. The next part was to see if coordinate 2, 7, 2, 1, 2, 3, 4, 5, 6, 7 was part of the solution. And this was only in the pink, not in the highlighted section. So 2, 7 is not part of the solution set. So 2, 7 is not in the solution set. Our next problem, we have y is less than, so we already have this in slope-intercept form, so that's nice. I'll put that one in pink. But our second one is not in slope-intercept form, so let's get that into slope-intercept form. We will have to divide by -3. That's the only thing that's wrong here. We'll divide by -3, so y is, since we're dividing by a negative, we have to flip our inequality to become greater than. We have a 1 divided by -3 is -1/3 x. -6 divided by -3 is a +2. So x-axis, y-axis. So our pink line will be at 0, 1, and a -1 divided by 3. So a change in y of negative, change in x of positive. So -1, +3, -1, +3. And I'll do it in the opposite way. Change in y of +1, change in x of -3. So 1, -3, 1, -3. And this is a dotted line. So I will connect these using a dotted line. I won't shade yet. The next one is we start at 2 and we have the same slope. So -1, +3, -1, +3, -1, +3. And we can also do +1, -3, +1, -3, +1, -3. And since this is greater than, not equal to, this is also a dotted line. And now to shade them. So for the pink, it says less than. So along the pink line, I'm going to go down. So this tells us that this is underneath. And then the blue is greater than. So along the blue line, I'm going to shade up. So above the blue line. Now, the solution set is where the blue and pink meet. In this case, the blue and pink do not meet at all. That means that since there is no intersection here, the solution is in fact no solution. So if there's no solution, then 2, 7 cannot be part of the solution because there is no solution. Those lines were parallel to each other and they are shaded away from each other. So there is no solution here. On this next example, our inequalities are already in slope-intercept form, so we can go ahead and start graphing them. I'll do the first one in pink. So I have x and y. Our y-intercept is 0, 0. Change in y of -4, change in x of +3. 1, 2, 3, 4, -4, 1, 2, 3, +3. -1, 2, 3, 4, +1, 2, 3. Or it could have been a +4 and a -3. So +1, 2, 3, 4, -1, 2, 3. +1, 2, 3, 4, -1, 2, 3. Now I can connect these. This is a solid line because it's less than or equal to. So I want to have it solid. And again, we'll wait on shading. Do my blue, which is the y-intercept is at 0, 0 as well. And it's at slope of -1. So -1 y, +1 x. -1 y, +1 x. -1, +1. -1, +1. It looked like the graph was going to be almost the exact same, but then it changed slightly. So then we can also go positive 1, negative 1, positive 1, negative 1, positive 1, negative 1. This one will also be a solid line. So I will connect these using a solid line. And now we will be able to shade. So for the pink, it is less than, so I'm going to go along my pink line and less than underneath. So all along that pink line, I'm shading underneath. And then all along the blue line, it says greater than, so I'm going to shade up. So shading above that blue line. The location which they meet is actually up in this little sliver right up in here. Our solution is right in that little sliver. So I'm going to highlight inside that little sliver. That's our solution set. So then we also look for 2, 7, which is only in the blue section. So 2, 7 is not in the solution set. On this last one, we need to put this first inequality into slope-intercept form. So on this one, I will actually add this y to the other side so that it's on the left. So I'll have positive y minus x is less than 4. Now I can get y by itself by just adding the x to the other side. So we'll have y is less than positive x plus 4. I did not have to worry about the negative because I added it to the other side, which does not affect the inequality. Then the second one is already in slope-intercept form, so we can go ahead and graph both of these. So I will graph the first one in pink. My first coordinate is 0, 4, 1, 2, 3, 4, and slope is positive 1 over positive 1. So y is 1, x is 1. Connect. So, and then it can also be negative 1 and negative 1. This is a less than, so it's not equal to, meaning it will be a dotted line. And then our second one, which we'll graph in blue, it's already in slope-intercept form, so 0, negative 6, 1, 2, 3, 4, 5, 6. And our slope is positive 1. So these lines are also parallel, just like example 4 was. But let's see what happens when we shade them. This is a greater than or equal to, so that means our line is solid. We'll have our solid line here. And now let's shade. So for the pink, we wanted it less than. So it's going to come underneath the pink. All of that underneath the pink. So it's already hitting the blue, so there should be a solution. The blue is greater than or equal to, so everything above the blue, all the way along. So it looks like in between these is where our solution is. So everything in between them is a solution all the way along. And remember, this goes on forever. It's not just the pieces that we see, but it does keep going on forever. So that's our solution set. So the last part is 2, 7 part of the solution set. So 1, 2, 1, 2, 3, 4, 5, 6, 7 is right here. 2, 7 is located here, which that is not part of the solution set because it's above the pink, and it's even if it was on the pink, that would be a dotted line. So 2, 7 is not accurate because it would say that 7 is less than 2 plus 4 is 6. 7 is not smaller than 6. That is not true. So it does not work. So we can say that 2, 7 is not in the solution set.